Dr. Kaku, I just wanted to mention that you spoke at in May at the science. There was a science convention in Manhattan at the Center, and I was one of the people who attended.
I see.
It was the World Science Festival on May 28th, and I just wanted to tell you that I did see you there, and I just thought it was a wonderful presentation.
Oh, well, thank you. I spoke about parallel universes and the real cutting edge of quantum physics.
It was a very interesting show and a lot of very interesting physicists discussing their theories. And, of course, Mark Everett, who comes along as the novice and brings humor to the whole hour.
That's right.
And Parallel Universes, that's one of your books, isn't it?
That's right, Parallel Worlds. It won a number of science awards. It was, in fact, a finalist for the Samuel Johnson Prize for Nonfiction in England. That's their equivalent of the Pulitzer Prize. So it was a finalist for the Nonfiction Prize.
And our listeners can find that actually right on the description page of today's show. You will see 3 of his books, and you can click on them. It's an instant sell through Amazon.com, and I encourage everyone to do that. It's great. You can just purchase it right this second. So, Dr. Kaku, I know that, well, do you like to actually be called Professor, by the way?
Professor is fine.
All right. You're teaching today, right? You've taken time off.
I'm on summer vacation right now, so I have time.
Great. Well, would you like to start maybe by just giving us a brief summation of your book, so that, because I think most of our listeners today would be more like lay people like me, just not knowing too much about science.
Right. Well, you know, when we watch the movies or read fiction, we encounter some of the dazzling possibilities of science fiction, like invisibility, teleportation, force fields, ray guns, telepathy, even UFOs, starships, and maybe even time travel. Well, I'm a physicist, and we actually work in these areas, and we do think that many of the so-called impossibility of science may be possible in the coming years, maybe even centuries. Just this week, for example, at Berkeley, where I got my PhD years ago, a breakthrough was made in invisibility. We can now take an object in 3 dimensions and make it invisible in one light. Of course, that'll take more years before we can make Harry Potter disappear. But the proof of principle was demonstrated. It was demonstrated 2 years ago at Duke University for microwave radiation, which is invisible. But this week at Berkeley, they show that you can make visible light bend in a way that would make Harry Potter invisible. So many of the fantastic things that we see in the movies, we see in fiction, are coming to reality. And that's the basis of the book, Physics of the Impossible.
In my world, this is Ellie, in my world, which blends metaphysics, which is the impossible to many thought, it is slowly merging with physics. So you have metaphysics merging with physics, just as you speak of science fiction merging with science, because what seems to be shown to everybody is that nothing is impossible and all things are interrelated on some level.
That's right. Take a look at teleportation. You know, we all know the expression, beam me up, Scotty. And we kind of laugh when we see in science fiction movies objects being teleported across a room. However, we've actually demonstrated that at the atomic level in the laboratory. BBC Television flew me out to Vienna in Austria, where the world's first group of physicists actually teleported particles of light across the Danube River, a distance of about 500 meters. Next, we're going to teleport photons to the space shuttle in outer space, and after 2020, perhaps even to the moon when we go back to the moon. Atoms have now been teleported. Beryllium, cesium atoms have been teleported. However, there are some drawbacks. For example, with regards to invisibility, one drawback is that you have to drill 2 holes for Harry Potter to see outside. That means that anyone looking at Harry Potter would see 2 eyeballs floating in air, and everything else would be invisible. So that's a problem that we still have to solve, how you look out the invisibility cloak without being seen from the outside. And teleportation is a problem, too. You have to be destroyed in the process of being reassembled someplace else. And that raises metaphysical questions like, what is the soul? If you just saw your atoms dissolve, like in the movies, and you reappear across the room, who is this person over there? Was the soul also teleported? These are questions that we're beginning to ask now. Can you teleport a soul?
When you, the whole question of teleportation also goes to Star Trek, Beam Me Up Scotty, things we see on all the good sci-fi shows, and it also reminds me of the space elevator. Which is both science and science fiction, and hopefully one day into science. Can you explain how the space elevator relates?
Yeah, if you take a ball on a string and you twirl it, centrifugal force prevents the ball from falling down. Now, if that ball is actually a satellite in outer space that is then anchored to the Earth, it will also spin around the Earth, and if it spins fast enough and the length of the string is long enough, then it becomes like Jack and the Beanstalk. The beanstalk was what Jack used to climb his way to heaven in the fairy tale. And we physicists now believe we can create the space elevator. You simply get into an elevator, push the up button, and shoot your way into outer space. Now, the key ingredient is something called carbon nanotubes, which is going to revolutionize chemistry. You can put the Brooklyn Bridge on a very thin wire of carbon nanotubes. It's the strongest substance known to science, much stronger than steel. Steel will snap. Steel cable cannot hold a space elevator intact. But carbon nanotubes can. And NASA takes this very seriously. NASA even has a contest with several $100,000 prize to any organization that can gradually work their way up to building a space elevator that will take you into outer space. Realize that to go into outer space today, it takes about $10,000 to put a pound of anything into orbit. Imagine your body made out of solid gold. One gland made out of solid gold. That's the cost of what it takes to put you into orbit. With the space elevator, you could reduce the cost by a factor of 1,000.
I knew I should stay on the diet, definitely.
However, to be fair, I have to say that the space elevator is still far in the future. We're talking decades to get a cable that strong and that long. But carbon nanotubes show that it is possible.
Amazing. And how long did you say, like, all right, say we have one and I'm getting in it now. Now, how long is it going to take me to get there, to get in outer space?
Right now, on a booster rocket, it takes you like 5 minutes or so to work your way up to about 18,000 miles per hour. The space elevator will be slower. It would take on the order of, half an hour or so to slowly, rise up. And eventually, you could even get past the satellites. You can go past the space shuttle. We're talking about a cable tens of thousands of miles long. It was first conceived about 100 years ago by a famous Russian engineer. He saw the Eiffel Tower, and he thought that if the Eiffel Tower were big enough, it would then never fall down because of centrifugal force. He did the calculation, and he was very depressed to find out that a steel Eiffel Tower would snap. But to him, it was the Eiffel Tower to the heavens. This is Konstantin Tsiolkovsky, who dreamed about this over 100 years ago. And now we think it's possible, and NASA takes it very seriously.
Well, when you, that brings one quick question I have about when you get your ideas, Professor, do they come to you with just any time or more like when you're asleep or for, let's say, your book, do you just constantly jot down your thoughts or carry around a tape recorder, or how do you do that?
Yeah, well, you never know when that spark of imagination is going to hit, and you're struck like a thunderbolt, and an idea springs to mind. However, in the laboratory, ideas are few and far between, but hard work, as Thomas Edison said, discovery genius is 90% perspiration and 10% inspiration. And that's the way it is in the laboratory today. A lot of hard work. Let me give you an example of hard work. We scientists have tried to access the brain with a computer for many, many years, and we failed. It's been very difficult because the brain is not really a computer. The brain is a learning machine. However, at Brown University, because of this very patient process, they succeeded, and it made the front page of all the science magazines. They took a stroke victim who is paralyzed, cannot communicate, basically a vegetable. They put a chip very carefully on the surface of his brain, the left lobe, and they hooked the chip to a laptop computer. And after a few hours, the stroke victim, who was paralyzed, began to move the cursor on the screen. And this person can now surf the web. He can answer emails. He can type. He can respond to questions. You can email, and he might even email back to you. He can do crossword puzzles. He can do everything by pure thought, by simply thinking. He can move the cursor on a laptop, which in turn can do anything that you can do on a computer.
So in some ways, wouldn't you say that reality is pure thought?
It's coming very fast, the distinction between reality and fantasy. And in the future, this implant, which looks about 2 inches on top of his head, there are famous pictures of him, will be microscopic. And so, for example, if you're a student taking an exam, you may be secretly surfing the web looking for answers to the exam, and no one would know because the chip in your brain is microscopic.
We wouldn't do that, would we?
Oh, of course not. Of course not. No. We're honest people, right?
That's right. Especially when we get invisible.
Right. But that could be the future. The future could be that we simply think about things and things become invisible. For example, my colleague Stephen Hawking is fond of saying that time travel is not possible because where are the tourists from the future taking my picture? Well, maybe they're invisible.
Oh.
Maybe that's why tourists from the future aren't seen and we don't bump into them with their futuristic cameras taking pictures of us. Or maybe we're simply not photogenic enough or interesting enough for time travelers to visit.
When it comes to time travel and metaphysics, of course, we do this as consciousness, putting our consciousness ahead in time. A lot of people use this as a healing tool or just to learn about the future, and they overlap this with information brought back into dream time, into their visions, into their creativity, so that time travel on a consciousness level helps people develop in this reality. And we also have the whole concept of everything is happening in the now, which means the past, present, and future are all as one. True?
Well, we physicists are beginning to reanalyze what we mean by time. See, Newton thought that time was like an arrow. Once you fired it, it never stopped, it never deviated. 1 second on Earth is 1 second on the moon. Time travel is not possible. Einstein comes along and says, not so fast, not so fast. Time is a river, said Einstein. It speeds up, it slows down, and we measure this every day with our GPS systems. Our GPS satellites have to be recalibrated because time is a river. It does speed up and it does slow down, and we measure
it whirlpools as well.
Yeah, the new wrinkle on all this that's causing all the excitement in physics is that the river of time may have forks in the river of time, and the river of time may also have whirlpools.
Yes.
So the river may actually be bent into a pretzel. And so this is causing an enormous amount of excitement. A lot of papers are being published about this now in the physics literature. And it brings back the old question, what happens if you go backwards in time and meet your teenage mother before you're born and she falls in love with you? If your teenage mother just fell in love with you, then how can you be born? Because your mother and your father never met.
If my teenage mother fell in love with me, she'd be gay, so I'd never be born. You have to look at it that way, too.
So all these questions that used to tantalize us in the movie theater are now being discussed very seriously by scientists. Blueprints for possible time machines are actually being published in the literature right now. So this is a very hot topic that we're talking about.
When I think you say in your book, Professor, that the actual machine, time traveler machine, I don't know, I may have this wrong, but didn't you say it was like hundreds and hundreds of years off?
Yeah. In the book, Physics of the Impossible, I try to put things into 3 categories. Class 1 impossibilities are things that are really possible, but you have to wait a few decades before they come to fruition. Full invisibility, we're not going to have for a few decades. But already we can begin to access the human brain with a computer, and already we can make objects on a small scale invisible. Class 2 impossibilities are what you mentioned, things that would require hundreds of years to really do at will. That is, simply by pushing a button to be able to go backwards or forwards in time. To go forwards in time, by the way, we can do that now. Our astronauts, when they go into outer space, they come back just like a microsecond or so different than our stream of time when they go into outer space. But to go backwards or forwards in time at will by pushing a button, that'll take hundreds of years of research. Then there's class 3 impossibilities that are probably just impossible, like perpetual motion machines. I get telephone calls from the Wall Street Journal a lot because there are inventors saying that I have now solved the energy crisis, and they get millions of dollars from private investors who think, yes, this guy has invented the solution to the energy crisis, and they want a quote from me. So I quote back to the Wall Street Journal the words of P.T. Barnum, who once said, quote, "There's a sucker born every minute." These machines don't work. They're scams. They're scam artists. And there's a long history of scam artists going back hundreds of years. Even the President of the United States once, President Garfield, was scanned by a perpetual motion guy. When many of these people advertising perpetual motion machines and got a lot of Wall Street investors to invest in their machines, after they passed away, their heirs looked at their house and they found all sorts of trapdoors, secret vents, tubes by which they faked their perpetual motion machine. They're all fakes, basically.
They're fake. I was just reading that in your book, that how they went in and checked the house and it had some kind of air machines or something that were...
Yeah, so unfortunately, the energy crisis is a very real crisis. There's no easy fix. And don't put your money in any investor who claims to solve the energy crisis instantly with his snake oil.
I agree. That does go back to the 18th century, doesn't it?
Yeah, there's a whole history of these things that I mentioned in the book.
Yeah.
With the 3 classes that you mentioned, class 1, 2, and 3, can these classes shift categories? In other words, if something is class 3, impossible for a very, very long time, can it move itself up?
That's possible if we have a better understanding of physics. See, right now we have 2 pillars of modern physics. All modern physics can be summarized in 2 theories. The first is relativity, which gives us black holes, it gives us time dilation, it gives us the atomic bomb, okay? The sun shines because of relativity, because of E equals mc squared. Then we have the quantum theory, and the quantum theory makes this phone conversation possible. Lasers, the internet, radio, television, microwaves. Modern society depends on the quantum theory. These 2 theories allow us to explain everything we see around us. However, there are gaps in our understanding. The quantum theory is the most bizarre, strange theory ever proposed in the history of science. Electrons can be 2 places at the same time. Electrons can disappear, reappear someplace else, and that's called modern electronics. If you're an electrical engineer, you just get used to the fact that electrons disappear, reappear someplace. They're 2 places at the same time. We just get used to it. But some people are not satisfied. I mean, if electrons can do it, why can't we? Einstein had a hard time getting his head around this. He just couldn't believe that electrons could dance and disappear and reappear someplace else. But Einstein was wrong. This is one case where he was actually wrong. And, for my students at the university, I actually do demonstrations showing that Einstein was wrong. We show that electrons can split and go into 2 places at the same time. And these are mind-boggling things. There's a lot of room for improvement. That's what I'm trying to say.
What about Tesla's theory? Because he was also very popular in the 20th century.
Who's this?
Tesla, Nikola Tesla.
Oh, right. Yeah, Tesla's a very sad story. He was a genius who invented much of the radio patents that we use today. He didn't have lawyers and people to help him, so most of the patents were stolen from him. A very sad story. And we physicists know the true story. So we wanted to make sure that the name of Tesla will not disappear. We have named the unit of magnetism after Tesla. 1T, T for Tesla, is the fundamental unit of magnetism. When you get an MRI scan at the hospital, for example, they expose your body to 1T, 1 Tesla worth of magnetism. So we wanted to make sure that this genius was not forgotten, because Edison was the genius who did have lawyers, and his patent survived, but many of the patents of Tesla were eventually stolen from him. Very sad story.
It is.
Well, Tesla, is it actually true that we are going to have a telephone where we can call the dead? Because there was a person that was actually on my show that claims that he has one.
Well, let me tell you this. We physicists work with things that are reproducible in the laboratory. That is, on command. You push a button, your machine either works or doesn't work.
Okay.
End of story, right? Now, when it comes to the dead, let me say one thing. The conventional view is that when you die, your body decays, you don't come back, and, end of story. Mm-hmm. However, the quantum theory does have this loophole. It's a rather disturbing loophole, but it's there in the equations. Mm-hmm. According to one version of the quantum theory, which I mentioned in Physics of Parallel Worlds, my previous book, mm-hmm. the world is constantly splitting apart into different worlds. Everything vibrates. That's why we have lasers. That's why we have GPS. That's why we have microwave radio. Your body vibrates. But these vibrations mean that your wave function can split apart in two frequencies emerge. Think of it as a radio. If you have a radio in your living room, your radio is tuned to one station. But your room is full of frequencies from other radio stations. Radio Moscow, Radio Havana, ABC Radio, CBS. They're all in your room simultaneously, filling your room, but your radio is only tuned to one frequency. Well, that's reality. Reality is tuned to one frequency, but in your living room, believe it or not, in your living room are the wave functions of dinosaurs, wave functions of dead people, wave functions of people who might have been born but never were born. And, it boggles the mind to think about this, but this is the leading theory. You can talk to most Nobel laureates, and they'll say, the many worlds interpretation of the quantum theory is the dominant interpretation of the quantum theory at the present time. I work in something called string theory, which we think is the ultimate theory, the final theory, the theory that eluded Einstein in the last 3 decades of his life. String theory naturally leads to a multiverse of universes. So in these other universes, believe it or not, your parents who may have passed away are still alive, or maybe they're not alive. But we are separated from them because we vibrate at a different frequency. We are decohered from them. This is called decoherence theory. We have decohered from these other universes where our parents are still alive. And as my friend Alan Guth likes to say, he may eventually win the Nobel Prize, by the way, for his inflationary universe theory. Alan likes to say, in one universe, Elvis Presley is still alive.
Oh. Wow. Well, we'd like to go see him. And you make that possible.
But I warn you that to detune, to overcome decoherence, we don't know how to do that. Just like your radio, you can tune the dial on your radio and pick up Radio Moscow, pick up WABC or whatever. But we physicists are clueless as to how to tune the dial on reality.
But it's getting closer, wouldn't you say? When I look back at, H.G. Wells, he wrote a couple of very interesting books, and he was a futurist, one could say, at the end of the 19th century going into the beginning of the 20th. He spoke about the time machine, which is what we've been talking about, the invisible man, that's invisibility theory, the war of the worlds, which goes to let's all travel to Mars and see who and what, and we discovered recently water is on Mars.
Also the atomic bomb. He predicted the atomic bomb.
Yes, he did, and weapons of mass, destruction. And it was really amazing that this man who lived over 100 years ago, let's say 100 years ago, was predicting things that were then considered impossible, right?
That's right. And in fact, he predicted that the secret of the atomic bomb would be revealed in the mid-1930s, and Leo Szilard, the physicist, read H.G. Wells, saw that he predicted that a physicist would invent the atomic bomb in the 30s, and then he went out to propose the chain reaction, which was the key to creating the atomic bomb. So it actually turns out that, I think, plus or minus 1 year, H.G. Wells got it right.
1933, he said, to be exact.
As to when the scientists would come up with the secret of the atomic bomb, which we now know is the chain reaction that sets off uranium.
So somewhere out there are prolific writers, physicists, scientists of all kinds, who in their own way are getting messages. They're creating things, whether it comes through their visions, their dreams, quantumly or just physically, but somewhere something is coming into their consciousness that they become very passionate about, and then
let me talk about dreams.
Yes.
One of the greatest mathematicians of the last century was an Indian mystic named Ramanujan. The name of Ramanujan will live forever in the annals of mathematics. He was a mathematical genius that just by thinking, he could write down these incredible mathematical formulas that even today dazzle the world of mathematics. He was like a supernova. Died very young. He was very young when he died, perhaps of tuberculosis. Many of his ideas came from dreams. Okay, his sister wrote about his brother, saying that it came to him in dreams. We now know what many of these dreams are. I work in string theory, which says that the universe is not three-dimensional, it's perhaps 10, maybe 11-dimensional, that there are other dimensions of space and time because of these enormous mathematical identities that have to be satisfied. In a 12, 13-dimensional universe, the universe is not stable. It decays down to 10 dimensions. These identities, these mathematical identities, were exactly the dreams of Ramanujan. When we physicists open the work of Ramanujan, we are shocked beyond imagination because the equations that popped into his mind as dreams are exactly the equations that we use in string theory.
And we also know there are no coincidences. Everything is a synchronicity and here for a reason. And that's another whole topic we study. How do synchronicities occur? How is it you meet the person you're supposed to meet when you meet them? You know, so that goes into more theories.
But I don't know. Professor, aren't there just like chance meetings? Or
there are chance meetings, too. Sometimes, for example, when you think about somebody and then the phone rings and it's that person, you think that, well, gee, that's great. It's synchronicity. Well, maybe, maybe not. But sometimes, most of the times you're thinking about somebody and the phone never rings. But you don't remember those things.
No.
So we do tend to remember those hits. And we have to forget the misses.
That's right. Well, your multiverse, your string theory multiverse, like we can go from one universe to the next, to the next, to the next, to the next. There's just billions, right?
Well, it depends on how you construct the gateway. The first inkling that there were these parallel universes came out in 1963 with mathematician Roy Kerr of New Zealand. He showed that if you take a black hole, the simplest possible black hole that's spinning, and you fall through the black hole, you actually fall through a ring. It's not a dot as we used to think. We used to think you die because a black hole is a dot. Now we realize that a spinning black hole collapses to a spinning ring, and it's held together because of centrifugal force. Anyway, if you fall through the ring, you don't die. You fall into a parallel universe. This is like the looking glass of Alice. Think of Alice's looking glass. The rim of the looking glass is the black hole. When you put your hand inside the ring, your hand winds up on another universe. So then the question is, what happens if you fall through the ring a second time?
Right.
It turns out you wind up on a second parallel universe.
Exactly.
And a third and a fourth. It's like an elevator button. Unfortunately, it's a one-way trip. You can't go back down again, but you can go up and up and up and go through different parallel universes. Then in the mid-1980s at Caltech, 3 physicists there showed that it is possible to hit the down button on one of these things. Not just the up button, but you can actually go back, return. These are called transversible wormholes, which then set off this explosion of interest among physicists because these gateways could become time machines as well, or gateways to another point in space and time, or a gateway to another universe.
With the mention of black holes comes my favorite topic. On September 10th, they are going to start up the Large Hadron Collider, and that has been of enormous interest to me over the past year. Is there anything you want to share about that?
Sure. First of all, it was turned on last week for low-power testing. It was turned
on the 9th, right? August 9th?
On Saturday, right?
Yeah.
For full-power testing, that'll be in September, as you said. And then the actual beam, the beam with all the collisions taking place, will take place shortly after September. So there is a lawsuit. In Hawaii that says that the Large Hadron Collider will perhaps create a black hole that'll eat up the Earth. And I've even seen animations on this. I was on CNN and Fox News talking about this. But, as a physicist, I've done the same calculation myself. And we realize that Mother Nature can create particles much more powerful than what we puny humans can create. The Large Hadron Collider is a pea shooter. It's a pea shooter compared to what Mother Nature creates every day. And whatever she creates hits the Earth. And, the Earth is still here. So the black hole idea, I think, is pretty far-fetched. However, you can calculate that the energy of all these subatomic particles would not light up a light bulb. The energy is microscopic. These are subatomic particles you can't even see, basically. And so that's why I'm not worried, and most physicists are not worried. But it makes a great story. CNN wanted to interview me. Fox News wanted to interview me.
About the Large Hadron Collider, what exactly are they looking for?
Okay, first, we hope to find what is called the Higgs boson, which is the last missing subatomic particle of the Standard Model. The Standard Model of subatomic particles is beautiful. I mean, it's very elaborate. It fits all the data, but it's the ugliest theory known to science. 36 quarks, Yang-nose particles, neutrinos, bosons. It's a horrible, horrible set of particles. It's ugly as sin. We hope that it's nothing but the lowest vibration of the string. The string is beautiful. The string is gorgeous. And the string's lowest vibrations give you the Standard Model. So when I got my PhD at Berkeley, I had to memorize the names of hundreds of subatomic particles. You can't get your PhD unless you know the names of the tau meson, the lambda particles, the rho mesons. I would hope that in the future, to get your PhD, you simply say, string, and you get your PhD.
Whoa! I can do that.
All these particles will be just musical notes on a vibrating string. So physics is nothing but the laws of harmony. Chemistry is nothing but the melodies you can play on these little vibrating strings. The universe is a symphony of strings. And the mind of God that Einstein eloquently wrote about in the last 30 years of his life, we now have a candidate for the mind of God. It's cosmic music resonating through 10-dimensional hyperspace. That, we think, is the mind of God.
Cosmic music. How beautiful is that?
Yeah, and that's where string theory comes in. This gibberish of subatomic particles with these bizarre-sounding names, hundreds of them with no rhyme or reason, we think we can explain. J. Robert Oppenheimer, the man who invented the atomic bomb, he was frustrated that we had so many subatomic particles. He was very angry about this. And so he said the Nobel Prize in physics should go to the physicist who does not discover a new particle this year.
Oh.
In metaphysics, we say that harmonics creates reality, and that kind of overlaps with what you're talking about.
Yeah, exactly. We're talking about the harmonics of vibrating strings that create the subatomic particles,
right,
which in turn create the atoms, which in turn create the universe. Now, the Greeks were the first to get onto this idea. The Pythagoreans, about 2,000 years ago, the Pythagoreans worked out the lyre music harmonies, the music of the lyre string, very much like a violin. And they were very happy. They were very pleased that they understood the laws of harmony, chords, thirds, fifths, and the different laws of harmony. But they thought that their theory of harmony could explain the universe. Well, that failed because they didn't understand atoms. Well, today we do have the atomic theory, but where do atoms come from? They come from subatomic particles. How many? Hundreds, thousands of subatomic particles. So why should nature litter us with all these subatomic particles? Because there's nothing but musical notes. And with the Large Hadron Collider, we hope to get the next octave. The next octave are called superparticles, or sparticles for short. And that's where the real action is. The real action is not to destroy the world with the black hole. The real action is to create sparticles, higher musical notes. That's what we hope to create with this $6 billion machine, which is 17 miles in circumference, bigger than the city of Geneva. It is the biggest machine of science ever constructed. And what we hope to find are higher musical notes.
Higher musical notes.
Right.
Symphonies. Oh, this is beautiful. I love the way you're describing this.
Yeah, and this is the very cutting edge of modern physics. This is where the next set of Nobel Prizes will come from. This is really exciting. All physicists are very excited about this machine.
I know. I've been reading about it ever since I heard about it, that it was almost ready. All I keep doing is reading about it and feeling the vibration of the strings. You're right about the strings and harmonics, though. You can hear it. If you're intuitive enough, you can actually hear it and experience it. And it has a mathematical base as well.
Mm-hmm. And this is, we think, what Einstein just almost got but never quite got there. Einstein gave us the fourth dimension, but now we think there are 10, maybe 11 dimensions. And Einstein believed in point particles. Now we believe in vibrating rubber bands or strings like violin strings. Mm-hmm. And he just didn't go far enough. When you go far enough, then you get into string theory. And then you get into these beautiful equations that seem to fit the particle data. And we hope to test it with the Large Hadron Collider starting in September.
In September. I don't want time to get by before we talk about your science program you're having on Sunday nights. I would love for you're going to be doing that for how long now?
Well, for 3 weeks running. It started last Sunday on August 10th. This Sunday at 9 o'clock, I'll be on the Science Channel talking about the future of medicine. And I'll be going to laboratories where they grow human organs from your own cells. Believe it or not, we can grow skin, bone, cartilage, noses, ears, blood vessels, and the first bladder was grown last year. The first liver will be grown within 5 years. Wow. And I flew down to North Carolina, Wake Forest University, and visited the laboratory. You'll see it this Sunday, the laboratory where they will grow organs as they wear out in your body. So in the future, when your organs begin to fail, your pancreas because of diabetes, your liver because of cirrhosis of the liver or hepatitis, will simply grow new organs. Also, they took a sample of my blood and they had it analyzed, and they had it analyzed for a few thousand genetic diseases. And Alzheimer's, for example, is a problem in my family. Some of it is genetic, some of it is not. So I asked them to analyze the ApoE gene, which predisposes you to Alzheimer's. And I'm proud to say that the ApoE gene was normal. There was no defect in it.
Wonderful.
Congratulations.
This is the future of medicine. The future of medicine is we'll be able to slow down the aging process. In fact, I even visit MIT where the age genes are slowly being teased apart. The so-called sirtuin genes, SIR1, SIR2, are involved in human aging. And we went to Wake Forest University where they grow human organs. And in Tennessee, that's where they analyze my blood. So the future of medicine will be this way. When you go to the doctor's office, it's not going to look anything like the doctor's office of today. We're talking about therapies that we can only dream about today becoming reality. That's
the field of biotechnology, correct?
That's right.
And I know that's expanding, and they're working with DNA also.
Right. And then the week after that, we talk about nanotechnology, which is even more powerful than biotechnology.
Oh, yeah.
Nanotechnology could give us a space elevator. It could give us what is called a replicator, which will create anything simply by asking for it. A replicator already exists. Mother Nature has already done it. Mother Nature can take McDonald's hamburgers and Coca-Cola and turn it into a human baby in 9 months. That's called the birth process. Mother Nature can take molecules and turn them into a human being in 9 months. So in the far future, not anytime soon, we physicists hope to replicate this, to create molecules that can shape other molecules, to create objects just by asking for it. And so, again, I go to MIT, I talk to the scientists who are working on this. This is called nanotechnology, the ability to manipulate atoms, individual atoms, and to become, in some sense, magicians. Magicians pull rabbits out of a hat. They take one object and turn it into a beautiful woman right before your eyes. We're experimenting with nanotechnology by mimicking Mother Nature. And Mother Nature does this. Mother Nature creates life out of chemicals. And we'll be able to have some of this power in the future. So in installment 3, I talk about the future of space travel, with space elevators, carbon nanotubes, and all the things that are going to change society in the next several decades. So that's for the following week. And then after that, I'll be introducing the Sunday lineup of shows on the Science Channel as a regular thing. I'll be a host introducing the shows on the Science Channel.
And all of this can be found on your website, which is listed right there on the description page, so that people can find the channel and read the descriptions more in depth and everything, right?
Mm-hmm. That's right, mkaku.org, mkaku.org. And so you can download videos, you can order books, you can see articles that I've written, and see where the cutting edge of physics is, where we physicists are going into hyperspace, higher dimensions, parallel universes, into the future. This is where science is taking us, and it's very exciting.
It is. Are we one, would you say, Professor? You know, you have the 1, 2, 3 levels. Are we a one?
Well, if you take a look at modern society as a whole, and then take a look in outer space for where societies in the future may be, we physicists rank them by type 1, type 2, type 3. A type 1 civilization is planetary. They control the weather. They have cities on the ocean. They control hurricanes. They control earthquakes. Type 1. Type 2 is stellar. They control individual stars, like in Star Trek. They can play with stars, play with a few black holes. Type 3 is galactic. They roam the galactic space lanes. They are maybe 1 million years ahead of us in terms of technology. Now, we're on this scale, what are we? We are zero. We get our energy from dead plants, oil and coal, dead plants. But we can dream about type 1. We're about 100 years from type 1. You just get a calculator and calculate when we'll be able to control the weather, when we'll be able to control earthquakes. 100 years is the earliest we can become type 1. And already we're seeing the beginning of a type 1 language, English. English is already the beginning of a planetary language for type 1. We're seeing the beginning of a type 1 economy. NAFTA, the European Union, all of them show the beginning of a planetary economy. We're seeing the beginning of a planetary communication system. It's called the Internet. What is the Internet? The Internet is the beginning of a type 1 telephone system. And we're seeing the beginning of a type 1 culture. If you've been watching the Olympics, you know that, gee, there is a planetary culture emerging. A lot of it is driven by music, driven by the movies, rock and roll, blue jeans, rap. You're seeing the beginning of a type 1 culture that cuts across national boundaries. And so we are privileged to be alive to witness the beginning of a type 1 civilization. That's where we are headed in the next 100 years. Globalization is just one tiny piece of this much larger picture, the birth of a planetary civilization. And we're privileged to be alive to witness it.
Wow, that is so exciting. We're right here and now, and we're becoming one world with no walls, and pretty soon, in a few thousand years, we'll be one galactic.
So I even give you a time frame. You know, we physicists can calculate when we'll become type 1, type 2, type 3. Type 1, we're about 100 years away from having this planetary civilization. A type 2 civilization would require a few thousand years, 2,000 to 3,000 years before we become type 2. Type 3, galactic, believe it or not, could take place as early as 100,000 years or maybe 1 million years. But, you know, when you take a look at the universe, which is 13.7 billion years old, we even know the age of the universe now, 1 million years is nothing. 1 million years is a blink of an eye compared to the universe. So when you look at the night sky, somebody could be looking back at you from another star. So far, we have discovered several hundred planets in outer space, circling other star systems. And next year, we're going to launch the Kepler satellite, which will discover maybe 600 Earth-like twins in outer space. This satellite we're very proud of, it's called Kepler. It's sensitive enough to pick up the vibrations from up to 600 Earth-like twins in outer space. So the next time, starting next year, when we look in the night sky, we'll have an existential shock, realizing that somebody could be looking back. And you'll point to the Big Dipper, you'll point to Pegasus, you'll point to Cancer, and you'll be able to identify which star which star has Earth-like twins revolving around the mother star. So this is really exciting. We're talking about a revolution in astronomy starting next year.
Wow, that is amazing. Looking back at us, you're talking about higher intelligentsias, right? Or
yes, or perhaps people that resemble us. Who knows? Who knows what's out there? Paul Allen, the Microsoft billionaire, was so enthralled by all these ideas that he donated $25 million to build a battery of radio telescopes north of San Francisco at Hat Creek to listen in, to eavesdrop on the conversations of these civilizations in outer space. So we scientists are thrilled that not only will we have a satellite next year that'll identify where these planets are located, we'll also have the ability to eavesdrop on their conversations, assuming they have these conversations, because a billionaire, Microsoft billionaire Paul Allen, has given us money to build a bank of radio telescopes to eavesdrop on their conversations.
Today is the 31st anniversary of the WOW signal.
Mm-hmm.
I'm sorry. The WOW signal, which was the radio, it was a radio signal from space, correct?
Yeah, it's still controversial. We don't know whether it was just a blip or whether it was somebody saying, hey, I want some McDonald's hamburger from the nearest star. We don't know what it was, but people call it the WOW signal because, hey, if it's really true, wow.
That's it. That's right. Well, I hope more people donate money and help us, find out more and more and more and more. That's cool. That is, this is exciting.
Yeah, so many things are happening. Large Hadron being starting up right now, even as we speak. Kepler going up next year in orbit. The Allen Radio Telescope Array getting an infusion of funds, and it's operational now. So we're entering a new era. And like I said before, where it's leading, what it all is leading to is the creation of a planetary civilization.
A planetary civilization. Well, I have to ask you, are you working now on another book?
Thinking about it, yeah. The Physics of the Impossible hit the New York Times bestseller list for 5 weeks running. It was the #1 science book in the country, and my publisher says, oh, you got to write another one.
Yeah.
This book was so successful. The first time a book with the word physics in it makes the New York Times bestseller list and stays on for 5 weeks.
But people want to know the same way they look up at the sky now and they say, there's got to be UFOs out there because everyone sees them, even the astronauts. So,
yeah, when people ask the question, what was the fascination with Albert Einstein, right? Why was he such a famous person? In some sense, he was a messenger from the stars, Ancient men and women have gazed at the stars and wondered, is anything out there? I mean, they couldn't give any possible answer. And here was a man, Albert Einstein, who decoded the secret of the stars. We now know how the stars shine because of E = mc squared. Matter turns into energy. That's why we have stars. And now we're getting instruments that'll be able to zero in on whether or not anyone's out there. So this is really an exciting time to be alive.
It feels like the movement of science is getting faster and faster and faster, considering where we were 50 years ago. Everything is so quick now. You learn your computer systems today, and in 6 months they're complete. Next phone system, next iPhone, next everything, which is wonderful.
Yeah, we know more about the universe in the last 20 years than in all of recorded history before 20 years. Take all the accumulated knowledge of the Greeks and people like Isaac Newton and whatever, add it all up, and it doesn't compare to the knowledge that we've gained just in the last 20 years.
Why do you think that is?
Well, several things. One is we have something called Moore's Law, which says that computer power doubles every 18 months, and it's like clockwork. You can actually predict how powerful computers will be next year because computer power doubles every 18 months like clockwork. Plus, I think modern societies now fund scientists. Scientists in the old days were wealthy individuals or they were professors, and by accident the king took a liking to you and funded your research. Kepler, for example, the greatest astronomer of that period, Kepler was the court astrologer. The king kept him on because he wanted to know what the stars told him the next day. Meanwhile, Kepler was working out the theory of the solar system. So now we have institutions of learning. We have great universities. We have great laboratories. Microsoft, of course, has great scientists working on software. And so we realize the importance of science. And science also sells. You know, computers sell like hotcakes.
Oh, yeah.
Especially with the next generation coming out every 18 months.
You've mentioned Kepler several times. When I think of Kepler, I think of the harmony of the spheres, which takes us to harmonics and string theory.
Yeah, he was the first one to propose that the heavens could have an order that is based on mathematics. And his theory of concentric polyhedra didn't pan out, but his philosophy did pan out. Einstein, of course, took that to the next level by trying to find beautiful mathematics to explain, the universe, the expanding universe, and light. And now we're taking it even farther, even beyond Einstein, to string theory and the Large Hadron Collider. So it's all based on this idea that Mother Nature is more beautiful, more elegant than we could possibly believe.
And actually simplistic. Isn't that what Einstein said?
Yeah, when people asked Einstein, is there a God, he actually answered that question directly by saying that there are two kinds of God. One is the God of the personal God, the God of intervention, the God of Moses, Isaac, and Jacob that parts the waters. But he said there's another type of God, the God of harmony, the God of Spinoza, Leibniz, Descartes, the God of simplicity, elegance, beauty. That's the God that he believed in. He believed that the universe was so simple, beautiful, elegant, that it couldn't have been an accident. If the universe was an accident, it would have been random. It would have been chaotic. We wouldn't have life and complex molecules and atoms. It would be ugly and random and chaotic and not interesting. But here we are, conscious beings, right? So that's why he thought that there has to be another type of God, the God of harmony, beauty, the God of Spinoza, the God of Leibniz.
Dr. Kaku, I don't want to keep you if you have to leave. If you can stay longer, we have more time allotted. It's totally up to you.
Unfortunately, I have another appointment with the faculty that I have to go to.
Okay.
They're starting up. But it's been wonderful to be on your show.
Thank you. I could just have you on 24 hours a day.
And perhaps
you're welcome back anytime.
Dr.
Okay.
Kaku, maybe perhaps we'll meet in university. You teach at the universities I attended, actually.
Mm-hmm. Right.
Graduate 1, undergraduate. Maybe I'll meet you at university one day.
Okay.
And I just have one passing message. People will be traveling with Virgin Galactic, into space. And my friend Stuart runs a travel agency in the city, and he sent me this email today because he thinks you're the most amazing person on the planet.
Oh, thank you.
And he said, can you ask Dr. Kaku if given the opportunity to go into space, would you go? And can he book you a ticket?
Well, my colleague, Stephen Hawking, wanted to go into space, and they put him up on what is called the Vomit Comet that gives you simulated weightlessness in the atmosphere. So he said, yeah, he'd sign up on a moment's notice to go into outer space.
Would you go?
Well, eventually, yes. I'm a little chicken. I don't want to be the first. Let the test pilots be the first, but I wouldn't mind being the second.
Thank you. We need you here. Don't go yet. Well, I appreciate it again, and thank you so much. And Ellie, thank you. You're just beautiful.
Very welcome. It's been my pleasure.
Okay, thank you very much. Glad to be in this show. And the website is mkaku.org, mkaku.org.
That's right. And all of your books, the 3 books, are scrolling across back and forth on the description page for anyone that will be listening now or downloading this. So, and everyone out there, I love you and have a beautiful day.
Okay.
Thank you, Doctor.
Okay, my pleasure.
Bye, Ellie.